Okay, this is part 1 of the Reteach over solving two-step equations. Make sure that you record your answers to the video questions on your answer sheet. Number one, we have an equation, and if I look for my variable, I see it right here. And then I'm going to split my equation into two sides. So I see that x is being added to 4. Okay, so to solve that, I'm going to do the inverse operation. So the inverse or opposite of adding is subtracting. So I'm going to subtract 4 from both sides. So 4 minus 4 makes 0, and minus 5 and minus 4, both of these numbers are negative, so it's like ninjas and ninjas, they're teaming up to make -9. Okay, so now the x is all by itself. So I have x equals -9. Okay, number 2, I've split my equation into two parts, and then I look for my variable. My variable is n, and it's over on this side of the equation. Next, I look to see what's happening to n. It's being multiplied by 4. So the opposite or inverse of multiplying by 4 would be dividing by 4. So I'm going to do that on both sides. Remember, one of the most important things about solving equations is that whatever you do to one side of the equation, you have to do exactly the same thing on the other. Okay, so this times 4 divided by 4 cancels itself out, so all I'm left with is that n, which is what I wanted. So on this side of the equation, I have n by itself, and on the other side, -16 divided by 4. So when I multiply and divide integers, that's when I'm thinking about the monkey face. So a negative divided by a positive is going to give me a negative answer. So n is equal to -4. Okay, so number 3, 4, and 5 are all two-step equations, so I'm going to have to do 2 steps in order to solve them. I'm always going to start by looking for the constant and doing the opposite of that first. Then I will take care of the coefficient. So starting with number 3, I'm going to go ahead and draw on a line to separate the two sides of my equation. I look for my variable. I see x is right here, and being added to x is a -8. So I'm going to do the inverse of -8, which is adding 8 to both sides. So -8 plus 8 makes 0, which is what I wanted, and 16 plus 8 makes 24. So now I'm going to go ahead and stop and rewrite the equation because I've changed a lot of stuff. This is gone now, and that -16 is now a 24. So I have 2x equals 24. So that x still isn't by itself because it's being multiplied by 2. So the inverse of multiplying by 2 would be dividing by 2. So I'm going to divide both sides by 2. So the times 2 divided by 2 cancel each other out, and I'm left with just that x. And on the other side, 24 divided by 2 is 12. So x is equal to 12. On number 4, let me just erase this line here. Okay. I'm going to go ahead and split my equation into two sides. So there's my equal sign. And then I look for my variable. So my variable is n, and I see that it's being divided by 5 and being added to 12. So I'm going to start by taking care of the constant first, which would be that plus 12. So the inverse or opposite of adding 12 would be subtracting 12. So I'm going to minus 12 from both sides. So plus 12 minus 12 makes 0, and 16 minus 12 makes 4. So again, I've changed quite a bit on the equation, so I need to go ahead and rewrite it. So now this is gone, but I still have the n divided by 5. So n divided by 5, and on the other side I have a 4 now. So my equation is still being divided. N is being divided by that 5. So the opposite of dividing by 5 would be multiplying by 5. So I'm going to multiply both sides by 5. And I'm going to write that times 5 up here next to the n, and then over here on the side. So times 5 divided by 5 cancel each other out to leave me with just n on that side. And on the other side, 4 times, that should be a 5. 4 times 5 will give me 20. So n is equal to 20. All right, number 5, I'm going to go ahead and put in my line to split my equation into two parts. I look for my variable. I have a y over here. I see that y is being multiplied by 0.2, and it's also being subtracted by 6. So of those two things, I'm going to take care of that minus 6 first, the constant. So the inverse of subtracting 6 would be adding 6 to both sides. So minus 6 plus 6 will give me 0. And then on the other side, I have a negative and 6 positives. So I have ninjas and pirates, which means they're going to battle it out, and I will be left with 5 pirates because I have more positives than negatives. So now that I've changed the problem, I'm going to go ahead and rewrite it. So on this side, I have a 5 now, and on the other side, this part is gone, but I still have that 0.2 times y. Okay, so that y is being multiplied by the 0.2, so I'm going to do the opposite of that, which would be dividing by 0.2. Okay, so the times 0.2 divided by 0.2 cancel each other out and will leave me with just y on that side. And then for the other side, I need to do 5 divided by 0.2. So I'm going to go ahead and rewrite that over on the side using the little division house. And I see that I have a decimal on the outside of the division house. I don't want a decimal at the door. So I'm going to slide my decimal to the door, go inside and slide once more. But when I look at my 5, it doesn't have a decimal. So I'm going to give it one, and I'm going to put it right here at the end. Just like I can say that I have $5, or I can say I have $5.00. And when I put the cents, I always put that decimal there at the end. So same thing. And now that I've given it a decimal, I can slide it one time like I did on the outside and give it a 0 there. So 50 divided by 2 is my new problem. That's really what I need to do. So 50 divided by 2, I know is 25. So now I go back to my equation and add that in there, that y is equal to 25. And I put a box around my answer. Our last problem is the modeling equation. Okay, and it does give you a key here on the side, and they will usually do that. and it tells us, that key, that the rectangle is x. And usually our rectangle will always represent the variable. And you can label it with that on the picture if you want. Okay, and then my squares are units. And since they're unshaded, I know that they're all positives. So you can, if you want, you could write the equation that you see and then solve it using algebra. So on the left side of the equation, we have 2x's plus 5 units. And on the other side, we have, let's see, 3, 6, 9, 10, 11 units. So then I could use my algebra to solve the equation if that's what you're more comfortable with. Using the picture, though, I'm going to look at where the x's are. So they're over here on this side. And I want to get rid of the constant or the units that's hanging out with them. So I have 5 positives there hanging out with my x's, and I want to get rid of them first. So I'm going to do 5 negatives on each side. So there's a negative, another one, and if I draw negatives on the left side, I have to draw negatives on the right side as well. So that will also create 0 pairs and take out some of my units. Okay, so now I'm going to cross out all of the 0 pairs that I have created to show that they are gone now. Okay, so now I have 2 x's left, and on the other side I have 6 units left. So each x will get 3 of those units, and I show that on my model by splitting it up or dividing it into 2 equal groups. So each x gets 3 of the units. So our answer was A, 3. If I had chosen to rewrite the equation and then use my algebra, then I would do the same thing on my equation. I would take out those 5 constants. So 5 minus 5 is 0, creating those 0 pairs. And 11 minus 5 leaves me with 6. So if 2x equals 6, then I can divide both sides by 2, making 2 equal groups, which means that each x gets 3 positives.